Okay, in this video, I am going to talk about the derivative of the inverse function of y equals e to the x. The inverse function of y equals e to the x is y equals ln of x. That is y equals log base e of x. Okay, in order to talk about it, I am going to want to talk about the properties of the derivative of the inverse function for functions in general. Okay, so please follow along with me in this argument. Okay, so let f be a continuous monotonic differentiable function such that f prime of x does not equal 0. Okay, and let y equal the inverse function of f of x. And that means that x equals f of y. Okay? Y is an implicit function of x, and so we can do implicit differentiation, okay, on this equation. So on both sides of this equation, okay? So we're going to take the derivative of f of y with respect to x on one side and the derivative of x with respect to x on the other. And so what we get is the derivative of f of y times the derivative of y equals 1. That is, the derivative of f of y with respect to x equals the derivative of f of y times the derivative of y, f prime of y times y prime, using the chain rule. Okay, and of course the derivative of x with respect to x is 1. And so by taking the derivative with respect to x on both sides of this equation, okay, we get this equation, okay? And so we can divide f prime of y on both sides to get y prime equals 1 over f prime of y, right? So now, whenever f prime of y does not equal 0, we have the inverse function of f prime of x equals y prime, right? Okay, that should be clear. Since the inverse function of f of x equals y, then y prime equals the inverse function of f prime of x. Okay, so so that must also be true. And since this is true and this is true, okay, we can put them together to get this. The inverse function of f prime of x equals 1 over f prime of y, okay, which leads to this equation. The inverse function of f prime of x equals 1 over f prime of the inverse function of f of x, okay? Since y equals the inverse function of x, we can replace y in this equation with the inverse function of f so that we get this. So now that we arrived at this expression, okay, write much more neatly that way with the 1 kind of put, more towards the center, but not completely, interestingly. Okay, so this is what we arrived at. So now we're going to apply this equation to the function e to the x. So let f of x equal e to the x. Then the inverse function of f of x is ln of x. And the derivative of the function e to the x is e to the x. And so, by going by this equation, we plug those in, we get the derivative of x is equal to 1 over e to the power of ln of x. Okay? Okay, so the derivative of e to the x is e to the x, and if we plug the inverse function ln of x into that function, okay, we get this. And 1 over e to the ln of x, of course, equals 1 over x, since e to the power of ln of x equals x. And now we get this. And so the derivative of ln of x is 1 over x. Okay? And this explains the conclusion of the previous video that talked about the integral, or the area under 1 over x, being logarithmic. And I concluded that by asking the question, well, what is the base? We now know that it is base e when we take the area from the fixed point x equals 1. Okay, and this concludes this video.